Hello everyone, I'm Wesley Assunção and I'm going to present this work done in collaboration with Jacob Kruger and William Mendonça, in which we present a challenge case aiming at calling the attention of the SPL community to the popular topic of microservice architectures. In a simple way, microservices are small and autonomous services that work together, usually by communicating via lightweight protocols. One of the advantages of microservices is that they are independent from each other, allowing development teams to work independently and choose different technologies. In addition, microservices are highly interoperable, enabling developers to integrate functionalities of different systems that are not implemented with the same technology. Part of the popularization of microservices is due to their adoption by big players, such as Netflix and Uber, as well as many government institutions that have to offer services to many people. Differently from many technologies widely used nowadays, microservices emerged in the industry and quickly became popular, and only recently have started calling the attention from academia. This scenario makes microservices a fruitful topic to conduct research and make practical contributions. In the scope of this challenge, we focus on the gap of variability in the context of microservices and microservices as a way to promote scalability for software product lines. For example, microservices are supposed to leverage reuse, but how can we combine microservices from different systems to create better variants? Also, the success of an SPL usually depends on the coordination among development teams, the technology choosing to manage variability, and does not have as a central concern improving non-functional properties, such as response time and scalability. So, microservices can bring benefits to software product lines on this regard. Based on these gaps, we propose this challenge case with the goal of fostering the application of SPL research and practice to the microservices topic, and the other way around. More specifically, we want to call the attention of both SPL and microservices community to initiate our research agenda in this cross area. This challenge can be a starting point to construct a body of knowledge between microservices and variability management. Well, our challenge case relies on 6 microservice-based systems in the same domain, namely web stores. These systems adopt different technologies, platforms, and vary on their size. Some of them are illustrative examples of some technologies, are well documented, and explored in related studies. It's important to highlight here that our challenge is different from the existing ones presented in the Software Product Line Conference. Because of the novelty of this topic, we can find only few studies in the literature, so we do not have enough information to construct a ground truth. Now I will present the 6 challenges. The first one asks researchers and practitioners to propose techniques to identify and locate features. Features can be implemented by the composition of microservices or split among many microservices. The mapping between features and microservices allows us reasoning on how to create building blocks using microservices and understanding the existing variability. As I have mentioned, there is no ground truth for this challenge. However, we have an initial mapping done manually to serve as a starting point to evaluate the proposed solutions. The second challenge focus on defining variability models that represent variability among the subject systems. The task here is to organize the building blocks, namely microservices, to make existing variability explicit and to allow engineers to systematize reuse, communicate to stakeholders, or plan the implementation of the microservices-based SPL. Similar to previous challenge, we do not have a ground truth, but we have conducted a preliminary study with the goal of providing initial feature models for the subject systems. Challenge number 3. Here we challenge researchers and practitioners to propose solutions defining an architecture. This architecture should represent the 6 web stores and present implementation for the microservices-based software line. Such architecture must allow the management of variability and leverage the reuse of microservices. As a starting point to evaluate the proposed solutions, we want to verify on how well the architectures proposed describe the 6 web shops and support the derivation of actual variants. We want proponents to describe how their solution supports the development of a microservices-based web shop product line. The 4th challenge asks for solutions focusing on interchanging microservices from different web stores. Interoperability of microservices is seen as one of the main benefits of this topic. So how the interoperability can allow reuse of microservices? For example, the same feature can be differently implemented in different systems. How difficult is the interchanging between such features? Another possibility is to evolve a web store based on the inclusion of a new feature available in another system. How much effort would it require? Of course, this is a wide open challenge without a single way to evaluate the solutions. However, we expect to observe how creatively and systematically proponents can propose solutions. Microservices are usually made available to users in a multi-tenant context. In other words, a shared infrastructure. This diverges a lot from the traditional way to deliver software product lines. Making systematic deep customizations, for example, fine-grained changes at the runtime inside microservices, targeting specific users, is an open challenge. Even more complex is to deal with the feature interactions in such as shared infrastructure. We can find few studies in literature with the focus on solving this challenge. However, they are in the very early stages and do not provide empirical validation of their proposals. Finally, the challenge number 6 have a wider goal of calling solutions that present the entire engineering of the subject systems to a microservice-based product line. In some way, this challenge is the result of solving all previous challenges. Here, the benefit of interoperability and modularity, as well as interdependence between microservices, is leveraged to allow composition of web store variants at runtime. In summary, we present a challenge with the aim of bringing together experts in software product lines and experts in microservices. As we pointed out, by default, both areas have similarities, but are advancing independently. A cross-area with similar research focus will benefit both of them. Basically, we believe that microservices can be seen as a building block to construct SPLs. In addition, calling the attention of our community This challenge also wants helping the creation of a body of knowledge and shed light on the new research and collaboration between communities. Fortunately, in the first year of the challenge we received 2 solutions already. That's all. Thank you for your attention and reach us if you have any questions.